So today we're going to be looking at conservation and dissipation of energy. Now, last time we looked at the law of conservation of energy, but let's remind ourselves as to what that is. Now, the law of conservation says energy cannot be created or destroyed. It can only be transferred from one state to another. Now, this here is a very important statement that you need to memorize for your exam. Well, there is something called dissipation, and this simply means to spread out. Or in the case of energy, it is meaning waste. Now, as I said, you cannot create or destroy energy, but when certain systems are occurring, there are ways for energy to be wasted. Now, some examples of causes for the dissipation of energy. Well, the first one is air resistance. And what this does is it transfers energy or waste energy into thermal energy. And the same goes for friction. You release heat energy via friction. And what this means is, let's say I was moving or running down a track. Some of the energy that I am expending is being converted into thermal energy because of the air resistance and the air molecules that are hitting me. So let's say we were to take my total chemical energy, and this is the energy that I will have stored in me because I've eaten food or had some sugary drink or whatever. And what I'm doing is then I'm trying to run. That is me running there. And what I've done here is I've converted my chemical energy into kinetic energy. If you were to work this out, you will notice that the chemical energy does not equal the kinetic energy. And this might seem that energy has been lost, but as we know, you cannot create or destroy energy. But what has in fact happened is the chemical energy has been transferred into kinetic energy plus thermal or heat energy because of the air particles that are hitting me. Now, this is not completely accurate. For example, as I'm running, my feet hitting the ground some of it will cause a bit of friction, but also you will, for example, hear a lot of sound energy or sound noise as well. So that is also another form of how energy can be dissipated. But at the end of the day, this thermal energy that we're releasing is a waste energy, and it means that the process that we are going through is not very efficient. So we want to try and minimize as much waste energy that we produce. So how can we reduce dissipation? Well, one form is lubrication. And this is, for example, in machinery. What this will do is it will reduce friction within moving parts of a machine. Now, this could simply be applying oil to a metal surface. Another form is simply by just adding wheels. Now, imagine you're dragging like a heavy object, like a table, across a room. That's going to be quite hard to pull it across like a carpet, for example. It's going to be a lot of friction. Imagine if you now were to add a set of wheels underneath that table, and that table is going to be way easier to pull. So wheels again reduces friction between an object and a surface. Some other forms are streamlining, which just means making something more streamlined, and this reduces air resistance. And there have been lots of work done to make objects more streamlined, such as buses, planes, Formula One cars, etc. As then it means that less fuel is wasted, or for example in Formula One you can get quicker race times. Now other forms are lower resistance in cables, for example in transmission lines, as this reduces energy dissipated as heat. And there's one more way that we can reduce energy dissipation, and that is thermal insulation. And we're going to look at this with a bit more detail. Now, we know that a lot of energy has been wasted trying to heat up people's homes. So we want to always find a way to make sure that we are keeping in as much heat as we can. That way we don't need to keep our heaters on for as long as possible. And the thing is, a lot of energy is dissipated through the walls of a building or your house. Therefore, there is something called cavity wall insulation. And this is where you have your house. So let's say you have your exterior wall here. So this is the wall of your house on the outside, and this is the wall of your house on the inside. So cavity wall insulation is where the walls are split up, and instead of having air in this gap here, what you now do is you replace it with some polystyrene. And this is a very good insulator. And with polystyrene being a very, very good insulator, what you're doing is you're reducing the amount of heat that is dissipated through your house's walls. And very good insulators are very bad at allowing heat to be transferred through it. This is one of the ways you can reduce dissipation in your house. So as I said, we've looked at cavity wall insulation. But other ways to reduce dissipation in your house, well, you could simply install a carpet or some floor insulation. In your windows, instead of having a single window pane, you can do double or even nowadays triple glazing. And this is where instead of having one window pane, you have two window panes, and in the middle you have a vacuum. That way, that vacuum is a very, very good insulator. You can have things such as loft insulations and also things called draft excluders. Now, minimizing energy wasted is not just something that we want to do in our homes. It's something that in every area of life. Now, that can be in something as racing or something in a chemical manufacturing process. There has been some level of research to make processes more efficient. And what I mean by efficiency is the ratio of useful output energy over the total input energy. So in other words, something that has very, very little waste energy is more efficient. So let's say I had a process that was going from chemical energy and I wanted to convert it into kinetic energy. But in one process, I convert it into kinetic energy plus heat energy, which I don't want, plus sound energy, which I also don't want. And in another process, convert the chemical energy into the same amount of kinetic energy and the same amount of heat energy, but this time no sound energy. And a final process where I convert it from chemical energy into the exact same amount of kinetic energy. Well, in this process, as you go down the list, you're increasing the efficiency of that process. So if I'm keeping the kinetic energy released in all these scenarios the same, what's actually going to take place is the chemical energy that I'm inputting is going to be greater in the first two scenarios, and even greater in this first one specifically.
Now, the best piece of advice I can give you after watching that video is to go off and practice some past papers or topic questions. These are single-handedly the best way to help you commit the content you've learned to memory. Obviously, go and do all the YouTube stuff of liking, subscribing, and if you found this video helpful, feel free to go and watch any of my other ones.